Sehr geehrte Damen und Herren, ich darf Sie nochmal herzlich willkommen heißen hier in der dritten Runde im kleinen Festsaal. Sie sind möglicherweise auch gerade erst von der Arbeit hier oder Sie sind schon länger und harren aus und haben draußen auch entsprechend die Speisen und Getränke genossen. Wir haben jetzt ein sehr spannendes Thema, ein für mich vielleicht jetzt noch unmögliches, aber später ist mir das sicher alles klar. Wie kann man kritische Infrastruktur in die Cloud verlegen? Eigentlich ein Widerspruch in sich, aber ich bin mir sicher, die Herren Wagner und Hudi, alle vom Austrian Institute of Technology, werden uns das jetzt sehr, sehr anschaulich und praktisch näher bringen. Bitte sehr.
So I switch to English now. Thank you very much for the introduction. Yeah, just shortly again, my colleague Alex Hudi and me, we are both from AIT, from the Safety and Security Department, and tonight we will talk about the topic critical infrastructures in cloud environments. And yes, we're not joking. How does this topic actually fit to today's motto? Well, Edward Snowden actually disclosed some very interesting information, I would say, last year regarding mass surveillance of the internet using world population, more or less. And how are they able to do that? How is the NSA able to do that? Well, they have money and they have people that have very good technical know-how. And you can assume also criminal organizations and of course other intelligence agencies, which are maybe not friends, and those exist, they have similar resources. So it's all the more important it is when you think about moving some critical infrastructure services to the cloud, that they do it in a secure way. The research project we are talking about today, it's called SECCRIT, Secure Cloud Computing for Critical Infrastructure IT. It's a 3-year project and it's funded by the European Union. And the AIT is coordinating it since the beginning of 2013. And next I would like to discuss with you the motivation behind the project and setting the scene. What are actually critical infrastructures? I would like to ask the audience, just shout out, and what do you think? What do you assume? Yeah, by definition it's assets or services that are essential for the functioning of a certain society. So in our case, some examples you've already mentioned. It's water and power supply, police services and military services, banking sector, agriculture, and even traffic control, for example, in some circumstances. Still at the moment, everything goes cloud. Just think about your consumer data, your emails, photos, more or less your internet life, maybe. Everything is more or less in the cloud. Even public administration IT services such as Finanz Online or other services by the Austrian government, they are more or less, it's not a public cloud, but they are running in a private cloud. And it's very likely that soon a lot of other applications and services, even critical infrastructure services, will move to the cloud. Why do you think would they actually do that? If that is really so critical, what do you think? Yeah, I think that's the main thing. It's about money, and it's even more important in times when of economic crisis as we have it at the moment. Money is even more important, and yeah, some of you have already mentioned it. Cloud infrastructures, they offer a possible reduction of costs by reducing the costs for having their own computing infrastructure. They have pay-as-you-use services, and they make it possible to manage peak loads. For example, when you have services that need, let's say, large-scale data mining operations. Cloud services are also characterized by their broad network access, which is also very interesting. So they potentially increase the availability of the services. Now back to the project. Well, the overall goal of the research project we are talking about today is to evaluate and to analyze cloud computing with respect to the security requirements of critical infrastructures. The use cases we have in our project are a traffic control center that's located in Spain, in Valencia, and a public safety CCTV system in the metro system in Helsinki. In the project, we generally say we develop methods, technologies for secure, trustworthy, and high assurance cloud services for critical infrastructures. Next to the problem definition. Well, different services, different cloud services, they have different requirements. For example, commercial services, like already mentioned, email and so on. The main focus is scalability and elasticity, one could say. In critical infrastructure domain, this is not as important as, for example, high availability, authenticity, and secure access of the services. That's everything very interesting, but what is actually the problem? When using cloud services, it is hard to determine. The technical reasons for security failures, because the whole system is very complex. Cloud providers may have sub-providers and providers that have actually the data centers. So it's when something happens, it's not clear what happened where. And also from a legal perspective, this is very important, and this is one aspect we cover in the project. So the big question is, who's to blame when something happens? The first of our two use cases, as already mentioned, is the traffic control center of Valencia. Well, they gather data from traffic sensors on the road, and they analyze this data and define mobility policies for the city of Valencia. And in fact, this data is actually pretty critical because the traffic lights depend on this data. What they in Valencia would like to do is to outsource the whole, more or less the whole infrastructure. Well, of course, not the workstations at the traffic control center and not the sensors on the road, but the rest of it they want to move to the cloud. Mainly because to make it easier when other cities are also interested in this traffic control system, then it's easier to also have city, let's say, when there is a big event in Vienna and people are coming from Graz or from cities around Vienna, it's easier to define the mobility policies when you have more information. Our second demonstrator is located in the metro system in Helsinki, and the idea they have is to outsource the whole video data they gather by the CCTV systems into the cloud. So this is, I will very soon come to that in detail. On this slide I want to show you the research outputs that we are focusing on in the project. So we have a techno-legal guidance. Then we have risk assessment approaches for cloud scenario. We have policy specification and enforcement framework, resilience management framework, and very important anomaly detection in cloud environment. Forensic analysis, cloud assurance approaches, which Alex will talk about later, and process-oriented security guidance. Today, we will focus on 3 aspects. We will roughly show you the legal aspects, the novel risk assessment approaches that we have discovered during the project so far, and the assurance approaches. When you start with a project and with a certain topic, it's very important that everyone involved speaks a common language. And it was very important at the beginning that we define what do we mean when we talk about the cloud. And at this point, I would like to ask you, what comes into your mind when talking about cloud? Interesting aspect, yes. Yeah. Pardon? Yeah. So everything you said is more or less true, and that's exactly the problem, because this whole thing of cloud is pretty complex, and when you want to develop something or you research in this area, you have to find a certain. In our way, we have to find our framework for the SECCRIT project. So. We have decided here between non-cloud and cloud, which is actually in the scope of the project, so we don't focus on the client side. Our framework has 4 levels. It's a user level, which is the client side, which we're not focusing in the project. Then we have the critical infrastructure level, or the service level. This is actually what you said, which is actually the, let's say, web service. It's not necessarily a web service, but it's a service, which is running in the cloud, and all those sub components. So the tenant level, this in our definition is virtual environment, so virtual computing, power, virtual storage. Yeah, and last but not least, we have the physical level, or cloud infrastructure level set, which is actually the data center. Let's come to techno-legal. So the image on the right side, I think you can see that this is also based on this framework that makes it easier to understand. A current legal problem for the cloud user, in our example on this slide, this is the Metro CCTV system in Helsinki. It's a security service operator. This operator wants to use some services from cloud providers. In our example, we have they use analysis services provided by cloud provider B. They use video management services provided by C. Yeah, and all those cloud providers they use some services by sub providers. They use database services, virtual servers, cloud storage, whatnot. The big question is, imagine that video data is leaked to the public. who is to blame? As you can see, there are many possible problems, and in the end, the one to blame is the security service operator, because that's the contract partner of the subway operator, and this cloud user is actually very interested in shuffling off the blame to someone else. So yeah, and at the moment there are no real techniques that deal with that. I think the assurance approaches, which Alex will talk about, is one aspect that deals with that problem. I would like to talk about the cloud risk assessment approaches we have developed, or colleagues of us has developed. So, when we started with our work on the risk assessment approaches on cloud infrastructures, we figured out that we have to consider different viewpoints or different stakeholders. In our case, that's the cloud service provider and the critical infrastructure provider. Yeah. Well, back to the framework. The cloud service provider is actually on top, and the critical infrastructure provider is the one that provides the data center. Another very important question is, when should the assessment be performed? There are 2 points, or two points, let's say. So at the moment, at the point of deployment, it's very interesting to check if even cloud can actually be used for this service or not. And it's also very important during the operation of the service. So let's say periodical checks after some changes in the deployment, if the risk is still acceptable in the end. Let's talk about our major contributions. It's actually two things. That's the first thing, maybe not so clear from the slide, but what we have developed is a catalog for threats and vulnerabilities for cloud cloud users, with a focus on critical infrastructures. So this is a snapshot. So we categorized the catalog, so mainly by the NIST definition. So you may know them: on-demand self-service, broad network access, resource pooling, rapid elasticity, and measured service. And this catalog is actually very interesting. So it's an Excel sheet, more or less, but with very relevant information, which you can take into account when you think about should I use a cloud for this service or not. You can check for common threats and vulnerabilities that are already known, and you can better decide if you can accept the risk or not. Last but not least, another contribution with respect to risk assessment was the extension of a maybe not well known but a common risk assessment approach. It's the very nice information security risk assessment process. Who knows about very nice from this audience? That would be very interesting for me. Okay. Optimistic? Yeah. So as the most risk assessment approaches, in the end, it's about getting the risk in numbers. That would be optimal way, let's say, and that you can decide is the risk acceptable, or what can I mitigate and what not. And we have extended this risk assessment approach with with cloud-specific attributes, which so in the end step 13 here, where you calculate the risk for the cloud environment, and in the end you compare the risk which you would already have without a cloud environment, and you compare it with the risk you get when you would give it to the cloud. So, Alex.
So, thank you very much. So what Christian detailed you before, what we are trying to deal within this project is that we are trying to assess the problem and tackle how the sensitive data and sensitive services are hosted in the cloud and how we can assure certain points of it. So the real questions are, what is assurance now at this point, and why do we need assurance, and how do we provide assurance? So what would you say from your perspective now, after, let's say, brief overview of what we are doing, what is assurance? What would you like to have as an assurance? Exactly. Anyone else? Exactly. This is the problem that we have currently in the cloud, because you may heard today several interesting talks where they presented you several different certifications of cloud. What this certification presents to you, it's a static analysis of the cloud. It's at some point of time some set of requirements which are satisfied. This is actually our problem that we're trying to tackle as well, how to provide this continuously. So you saw the architecture that Christian introduced earlier today. I abstracted it a little bit and showed what is our approach now. We're trying to tackle the assurance in several different levels. We're trying to provide assurance, for instance, at the physical level, virtual, and service level, and additionally abstracting it to a user. How is this possible? We're trying to investigate across the whole cloud how certain properties could be monitored, how we can aggregate this data, and how can we assess it. So, of course, the problem of dealing with this is large-scale data. So that's why these monitoring artifacts have to be carefully analyzed, have to be classified. This is what we are coming to into. This is how we come into the story with assurance. We want to have assurance classes that are associated with certain set of properties and they're measurable somehow. How? We want to, at the end of the day, provide to the user or to you and tell you, okay, our cloud or your service is assured at this level from, for instance, 1 to 7. How we are trying to deal and tackle this problem is so that we are analyzing, for instance, certain classes, particularly, let's say, refer now to the confidentiality, integrity, and availability, and we're checking it dynamically over the time at various levels and aggregating it towards the root. And then, at the end of the day, providing this to the user in an abstract manner, because user itself and you as a user, you don't care what's going on below. You just care that your services are insured. However, even if you care, you can then additionally require additional set of data where we can detail you then how and what's happening under the hood of the cloud. So furtherly, what we try to address with the research questions is actually how to assure security properties across the cloud where we have different cloud layers and different stakeholders. How we can provide continuous assurance assessment, how we can assess this assurance in terms of levels, and how we can aggregate or inherit it across the cloud. So, once again, abstraction and notation of our cloud architecture, and we're trying to envision and investigate properties like load balancing, access control, availability, encryption, and auditing. So, what does it mean now to you? Actually, nothing. These are just more or less notations. However, we're looking at them as properties because, for instance, if we have load balancing present at various levels, concretely, actually possibly at layer 7 and layer 4, we're seeing this as a property that would support availability, because this means if one virtual machine with running of the service fails, load balancing will redirect this HTTP request that's at layer 7 to some other machine. Encryption, concretely. I'm sorry? Encryption again, concretely. So we're investigating whether the encryption is present to each individual level and then continuously ensuring that this is present, because it's not just sufficient that our servers are encrypted. What about if in the middle our encryption is failing and we have some escalation of privileges on virtual machines and somebody could gain access to our data. So there are several projects that are investigating also the same thing or closely related thing with us. Actually, one of those projects are we as well. Cumulus project, which statically actually, for the time being, analyzes the security properties. They already define certification models and core certification mechanisms. In our case, how we contributed at the time being is that we provided methodologies for risk assessment and management. And most importantly, based on them, we found our assurance. And based on the notorious top 9 in order to show that we are actually aligning our challenges and our work towards the existing well-founded work. So now more concretely, this is the outcome of our assurance catalog, where we abstracted some of the properties and categories and identified them as identity assurance, data disposal, data deletion, quality level, but we'll come to that later. So once again, how we approached it, we used the common criteria approach, which is already well-founded and well-used. However, the problem of the common criteria is that they assess assurance of individual services till the production level. But what about in the production level, where we actually want to know what's happening under the hood of the cloud? This is where we are tackling the problem. We, therefore, use the common criteria as fundament of our work, where we use their approach in order to assess component of evaluation, group of evaluation, and target of evaluation as an abstract manner of a service inside of the cloud, where we define, for instance, the whole service hosted on top of the cloud as a target of evaluation with the individual components of interest that we try to investigate further. Then we define additional assurance profile, where we define assurance type, service assurance or data assurance, and then furthermore analyze different assurance properties classes aligned with objectives. And then most importantly, we have to watch on the assessment interval, because we don't want to be too invasive on the services. So furtherly, how do we abstract it concretely? We use the general tree-based model and abstract the service extract the service over several components that is connected with, and then try to individually assess them. And these components are then aligned with security properties, and each individual security property is aligned with the assurance level. But I don't want to bore you too detailed with this. Then, furthermore, how our model works is that we have tree traversal post-order method, which is used in order to aggregate this assurance properties towards the top, and then derive the assurance level of individual component and of the whole service as well. Of course, in order to do that, we have to have additional support for the policies for each individual step where we are aggregating the things, because we are treating with various information sets and various classes that we need to comprehend. So, more additionally now, real-world use case scenario would be where actually we are hosting some critical infrastructure service in the cloud, where we have a load balancer, several virtual machines hosting the services and load balancing the incoming requests, storing and backupping. So at each individual level, we want to investigate whether some backup has been conducted correctly, whether the data has been replicated across several different databases, whether it's done consistently, whether it's encrypted, etc., etc. Concretely analyzing this dynamically across time, and then providing, once again, abstract level of service to the user. So once again, in a nutshell, our ongoing work is related with security requirements, questionnaire which we are conducting in order to investigate not just what we want to do, but what the industry and research wants to conduct and what are their requirements. Furtherly, we're conducting process-oriented security guideline. This is also part of our future work, and developing assurance methodologies with OpenStack, because we set it up an OpenStack cloud at the AIT, where we want to actually conduct the assessment in a real-world scenario. And at the end, we want to develop anomaly detection prototypes. I know this has maybe been really fast to you, but we will try to provide, let's say, as much as possible details in a short point of time. And I hope that you understand at least part of it. If you have, however, any questions, please feel to contact us. We're welcome to answer any of them. If you're interested to work with us, of course, please approach us at any point of time. Thank you.
Thanks a lot for your explanations. Very interesting. Are there some questions at the moment?
what does tenant stand for?
Basically, in our case, tenant stands for the virtualization layer, so we call it tenant layer. Well, I can answer it, sure.
Have you any partners which are actually helping you with that? Because the assessment of like networks, Azure, Amazon, are they helpful, or are they providing you some help to that project, or nothing at all?
However, most important part is that public cloud providers will never let you dig into their cloud provider. That's why we set it up our own cloud. That's why we have OpenStack, and that's why we want to test an open source environment where we will penetrate through the services and try to aggregate the data that we actually need. Because, you know, if you go to Amazon and tell them, can you give us log data? Yeah, no way. Can you tell us where is our data? Yeah, maybe in US, maybe not. Maybe it's Snowden, maybe it's Russia. You never know. Yes?
You show some slides with more or less technical structure. Do you have also in mind all the companies who are necessary to operate this? For maintenance, for cleaning, for electricity. This means all this stuff who has physical and logical access.
If I understand your question correctly, please. Well, at one point, yes. At the other point, no, because actually, first of all, we're considering, as I said, only open source. This is our primary function, primary focus, because this is our, let's say, strength, because there we have ability to test everything. I hope I answered your question, but if not, yes?
My hint is regarding all these companies which are suppliers and you need it for maintenance. This means also carrier, network connections, this means electricity, cooling, and maintenance of servers.
Yes, this is all what we are actually considering. I'm sorry, I misunderstood your question. Yes, this is all what we are considering. However, at this point of time, because this is such a broad project, and as I briefly introduced you, we have Cumulus as a project partners. They only investigated one class for 3 years, and we are actually trying to tackle everything at the time being. But yes, but the problem is we have to distinguish first of all physical security and cyber security, and this is at the point of time really hard, because the abstraction and enumeration of these properties is also one challenge where we have to be, let's say, between high-level abstraction and lower-level technical details. This is actually the most challenging thing that we didn't expect, because developing methodology was quite easy, let's say, but now how to abstract the things, how to say that load balancing is our property, or is it just, let's say, virtual machine that actually accepts the request. This is exactly the venue where we are heading to, and then individual things that you mentioned that we need to consider in order to state, yes, our cloud is this level assured, assurance level 7 or assurance level 1. What is missing?
Could you put it that way, that you saw a problem with the certification, that it was like so static that, oh, you fulfilled all requirements, here you have your certificate, good job. And you wanted to make something more dynamic, more that adapts to problems that come up along the way?
Well, actually, adapting to a problem is unfortunately not at our scope. The problem is if you have a static analysis, at some point of time somebody tells you, I am secure PCI, I have PCI DSS certificate, which is a certificate for credit card processing. And who guarantees you that some of the disks have been correctly disposed? Because this is just a certificate that is given to you today, and in 1 year, who guarantees that this is the same? We want to provide information continuously to you, because you're interested that your service is running correctly, transparently, and safely.